Okay, so in this video we're going to be looking at the scenario where the circles are touching the x or the y axis, and I should probably say and or the y axis. So the general rule, really worth taking down, if it's touching the y axis, the radius is equal to the modulus of minus g. Okay, remember the center is minus g minus f. So if it's touching the y-axis, the radius is going to be the modulus of whatever that is. If it's touching the x-axis, the radius is going to be the modulus of minus f. So for example, if it's touching y-axis and its center O is 3, 4, the radius is going to be the modulus of minus g. Now remember, this is minus g minus f. So what's the modulus of 3? It's just 3. What if it's touching y-axis and its center O is minus 7, 2? Then the radius is going to be the modulus of minus g. So the radius is going to be 7. What if it was touching x-axis and its center O is 2, 3? Then its radius is going to be the modulus of, now take your time, it's touching the x-axis, so its radius is going to be the modulus of minus f. Minus f is 3. The modulus of 3 is 3. And if it's touching x-axis, and its center O is, 4 minus 1. Then its radius is going to be the modulus. It's touching the x, so it's going to be the modulus of the minus f. Minus f is minus 1, so the modulus of minus 1 is 1. And to help you visualize that then, I have a few examples. So a circle here, it's touching the x-axis. I know it's touching the x-axis, so I'm looking at the modulus of minus f. The modulus of minus f here would be 2, so its radius is 2. Here, it's touching both the x and the y-axis. So or is equal to the modulus of minus g, and or is equal to the modulus of minus f. The modulus of minus 3 is 3. The modulus of 3 is 3. So we know the radius is 3. Here we can see that it's touching the x-axis, so we're looking at and saying or is the modulus of minus f if it's touching the x-axis. We know the minus f is minus 4, so the modulus of minus 4 is 4, and you can see the radius is 4. Okay, so how does this get applied to a question? So find the equation of two circles. Okay, so we know we're going to be dealing with x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. The reason we know we're dealing with this one is because we don't, if we don't know center plus radius. If we know the center and radius, we would use x minus h squared plus y minus k squared is equal to r squared. But we don't know the radius and we don't know the center, so we're not going to be using them. We do know that this point should satisfy this equation. Okay, it should satisfy it. So find the equation of the two circles which contains the point. So I'd go 3 squared plus minus 2 squared plus 2g by 3 plus 2f by minus 2 plus c is equal to 0. 6g minus 4f plus c is equal to, this would be 9 plus 4, which would be 13, so it would be minus 13. That's our equation 1. Equation 2 is when we're subbing this in, so it's 2 squared plus minus 1 squared plus 2g by 2 plus 2f by minus 1 plus c is equal to 4g minus 2f plus c is equal to, the 2 squared would be 4, minus 1 squared would be 1, so you get 5, so it's minus 5 right here. Okay, fantastic. Now I have two equations, but I have two unknowns. Okay, so we can't really go too far because we have a g, f, and a c. We know it touches the x-axis. Okay, we know it touches the x-axis, so somewhere, let's think of what this looks like. We know that the circle is, it contains the point 3 minus 2, so we're going to be looking over here. Something like that. Okay, so maybe this might be 3. No. This might be 3 and this might be minus 2. Okay, something like this. What do I know about the radius? This radius, if it touches the x-axis, remember this is minus g minus f, or should equal to the modulus of minus f. What do I know about the radius? I know the radius, we had a formula for it. So equals square root of g squared plus f squared minus c. Okay, so if I use that instead of using the letter or, g squared plus f squared minus c is equal to, that's a 2, minus c is equal to the modulus of minus f. And what I have right now is an equation 3. Because how many unknowns are there? There's 1, 2, 3, and still f. So that's 3 unknowns. I can simplify that a little bit further. Get rid of the modulus by squaring both sides. So squaring a square root, I just get g squared plus f squared minus c is equal to minus f by minus f would be plus f squared. So g squared plus f squared minus c is equal to f squared. G squared minus c is equal to 0. And we can use that as our equation 3. So it's really useful to write down all 3 equations now that we have, 1, 2, and 3. 1, 2, 3. Okay, so I have 3 equations with 3 unknowns. This equation is kind of jumping out at me a little bit. Because it has g's and c's. It only has 2 unknowns, so that's quite nice. 2 unknowns is quite nice. Anything else that I can do? No, not really. I'd probably try and isolate in equation 3 here. If I go c is equal to g squared, just from adding c squared to both sides. Now I can add this into equation 1 and equation 2. Okay, so watch. I'd get equation 1 would be now 6g minus 4f plus g squared is equal to minus 13. Equation 2, 4g minus 2f plus g squared is equal to minus 5. Now there are only 2 unknowns. Let's try and get rid of the f's because I have a g and a g squared, which would be nice to deal with. So equation 1 I'm going to leave alone, and equation 2 I'm going to multiply by minus 2. 6g minus 4f plus g squared is equal to minus 13, minus 8g plus 4f minus 2g squared is equal to 10. We're getting minus g squared is equal to minus 3 and minus 2g. And we have a quadratic equation then. So I can bring this up. G squared plus 2g minus 3 is equal to 0. G plus 3 minus 1 g is equal to minus 3, g is equal to 1. Let's use that to find c. C is equal to g squared. C is equal to g squared. C is equal to minus 3 squared. C is equal to 9. C is equal to 1 squared. C is equal to 1. Okay, so let's sort of color code these so I know I'm keeping them together. The green ones with the green ones and the black ones with the black ones. So I've got the 2g and c now. I need to go and find f. So I can find f from equation 1 or equation 2. Neither of them look easier than the other, so I'm just going to take equation 2. I'm going to manipulate it. I'm going to go 4g plus c plus 5 is equal to 2f. F is equal to, I'm going to divide everything by 2, or multiply everything by a half, 2g plus a half c plus 5 over 2. F is equal to, now I need to do both options, the black option and the green option. And actually, to make this look nice and easy to follow, I can change the color of the pen. Green option. F is equal to 2 times minus 3 plus a half times 9 plus 5 over 2. F is equal to minus 6. I'm going to take a second and use calculator. Put that into your calculator and you get 1. And then we're going to do something very similar on the other side. F is equal to 2 times 1 plus a half times 1 plus 5 over 2. F is equal to 2 plus 0.5 plus 2.5, which would be 5. And now we have our two equations then, because I can just sub all of that into x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And we're getting the black one, x squared plus y squared plus 2 times minus 3 x plus 2 times 1 y plus c, which is 9, is equal to 0. X squared plus y squared minus 6x minus 2y plus 9 is equal to 0. 9 equals 0. And we are getting x squared plus y squared plus 2 by 1x plus 2 by 1y plus 5 is equal to 0. X squared plus y squared plus 2x plus 2y plus 5 is equal to 0. We've gotten two equations. Both contain the points 3, minus 2 and 2, 1. And both touch the x-axis. Okay, how about this question? The x-axis and the line y equals 8 are both tangents. So a little bit of a diagram can be really useful here. The x-axis is a tangent, and the line y is equal to 8 is a tangent. Now that's really important. What does the line y equals 8 look like? Well, I've talked about it before in this. It's really important to know that this is horizontal. What it's telling you is every y coordinate is 8 on this line. So it contains the point 0, 8, 3, 8, 7, 8, 1,000, 8. So it's a horizontal line, and it looks like that. And I know this value here is 0, and this value here is 8. Okay, well, if both of those are tangents, that means the circle must fit in somewhere perfectly. It's either perfectly inside there, perfectly inside it there, perfectly inside it there. I don't know, but it's somewhere in there. So we know the diameter is 8, which the knock-on effect means the radius is 4. And the knock-on effect of that, before I go any further, what formula do I know of the radius? G squared plus f squared minus c. So I know I have an equation straight away. G squared plus f squared minus c is equal to 4. G squared plus f squared minus c is equal to 16. Boom, equation 1. The center of the circle lies on this line. Okay, well, what's the center of the circle now? I'm going to remove that circle there and put it somewhere arbitrary. Like here. The center of the circle. We know the center of the circle is minus g minus f. So if the center lies in that line, it means minus g minus f must satisfy that line. So I could sub in minus g and minus f, and it should make sense. So I'm getting minus 2g plus 3f is equal to 0. And I like having the g's positive, so I'm going to go 2g minus 3f is equal to 0. Okay, well, is there anything else I know about it? Well, I know the center is going to have to be here, and that should be minus g minus f. But I've already stated that I know the radius is, what's the radius? The radius is 4, because it's half the diameter, yeah? If the radius is 4, that tells me, I want this to be perfect, there we go. If the radius is 4, that tells me how high up off the x-axis it is. Well, if it's telling me how high up off the x-axis it is, it's also telling me the y-coordinate. I know this y-coordinate is 4. So that means the center is really minus g 4. So from this I can say that minus f is equal to 4, or f is equal to minus 4. This was my equation 2. This is really my equation 3. If I sub equation 3 into equation 1 and into equation 2, what do I end up with? I end up with equation 1 looking like g squared plus minus 4 squared minus c is equal to 16. And equation 2 is 2g minus 3 minus 4 is equal to 0. Equation 1, g squared plus 16 minus c is equal to 16. Equation 2, 2g plus 12 is equal to 0. Oh, well, equation 2 is very telling here. There's lots I can get from that. Let's keep tidying up equation 1. G squared minus c is equal to 0. Equation 2, 2g is equal to minus 12. G is equal to minus 6. Now I have that. I have f. Now I can use equation 1 here. C is equal to g squared. C is equal to minus 6 squared. C is equal to 36. Let's write out the equation that we know. We know it's x squared plus y squared minus 2gx plus 2fy minus c is equal to 0. X squared plus y squared minus 2 by minus 6x plus 2 by minus 4. Oops, this look better. Minus 4y minus 36 is equal to 0. X squared plus y squared plus 12x minus 8y minus 36 is equal to 0. And that's the equation of the circle. And I've just realized a mistake that I've made. I don't know why I wrote that down as a minus. That should be plus all the way down. You probably noticed it yourself. This should be plus C, and plus C. Okay, and the last example then. So the x-axis and the line y is equal to 10 are tangents. So first things first, always draw out a little sketch for ourselves. Y is equal to 10. Y is equal to 10, just going horizontal. This is the line y is equal to 0. This is the line y is equal to 10. The line y is equal to 0 is also known as the x-axis. We know the circle fits in somewhere in here. We know the radius is going to be 5. So that's g squared plus f squared minus c is going to be 5. G squared plus f squared minus c is equal to 25. Brilliant, equation 1. I know the center is minus g minus f. So I know that minus f is going to be 5 because, again, this distance here is 5, which means this distance here is 5, which means this coordinate is 5. So if minus f is 5, f is minus 5. Let's sub that into equation 1 straight away, sure. Equation 1, we're getting g squared plus minus 5 squared. So it'd be plus 25 minus c is equal to 25. We're getting g squared minus c is equal to 0. Brilliant, equation 1. What else do we know? We know the circle also contains the point 1, 5. So, use green. We know 1, 5 is on the circle, so 1, 5 should satisfy x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So it's x squared, 1 and 5. 1 squared plus 5 squared plus 2g by 1 plus 2f by 5 plus c is equal to 0. 2g plus 10f plus c. 1 squared is 1, 5 squared is 25, 1 plus 25 is 26. We get minus 26 then. But we also know what f is. So let's bring that down. We know what f is. So we're getting 2g plus 10 by minus 5 plus c is equal to minus 26. 2g minus 50 plus c is equal to minus 26. 2g plus c is equal to 24. Brilliant. Now I have an equation with g and an equation with c. Or two equations with g and c, sorry. So equation 1, g squared minus c is equal to 0. Equation 2, 2g plus c is equal to 24. Add them together. We get g squared plus 2g is equal to 24. G squared plus 2g minus 24 is equal to 0. G squared plus 6, sorry, not g squared, g plus 6, g minus 4 is equal to 0. G is equal to minus 6. Don't need a bracket on that. G is equal to 4. That will help me get C. I'm going to do two colors here as well. G is equal to 4. That's going to help me get C. C is equal to G squared. So C is equal to minus 6 squared. C is equal to 36. C is equal to 4 squared. C is equal to 16. And we knew F already. F was minus 5. So we're subbing that into your x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, not minus c, like the mistake I made in the last one. X squared plus y squared plus 2 by g, so 2 by minus 6. Well, I'll take my time. 2 minus 6x plus 2 minus 5y plus 36 is equal to 0. X squared plus y squared minus 12x minus 10y plus 36 is equal to 0. And then the blue one, oops, there we go, x squared plus y squared plus 2 4x plus 2gx, which is 4, plus 2 minus 5y plus 16 is equal to 0. X squared plus y squared plus 8x minus 10y plus 16 equals to 0. Done. Equation 1, equation 2, or circle 1 and circle 2. That's it for coordinate geometry of the circle. Would highly recommend going on and looking at some exam questions now. Yeah, hopefully you didn't find the topic too hard. With coordinate geometry line and coordinate geometry circle, they're really, I can't see them never not coming up. Or I can't see them ever not coming up. They're really banker of questions, so I'd really put the work into them. There's no sort of formal proofs to them either, like trigonometry or geometry, so a lot of people like them on that. So guaranteed sort of banker of a question on paper too, so really do put the work into it. Hopefully you found the videos useful and the topic not too difficult.